Okay, this particular rock here is part of a unit called the Urbana Formation. Again, named for the town of Urbana in the western part of Montgomery County. And you can see the layering in this rock here. This rock, in contrast to the slate we saw earlier, does show bedding in it. So this was not a constant environment. We had layers of lime clay, very, very fine-grained calcite, laid down probably by algae, and layers of clay minerals laid down at different times, and that's the origin of the bedding. This also does show cleavage. It breaks along this line here, which is not parallel to the bedding. So the cleavage was developed when this area was metamorphosed, when it was cooked under pressure, but very low-grade metamorphism. The limestone is now a fine-grained marble, and the layers of clay are now phyllite because of the development of new sheet silicates in them. So the fact that this is a rock that shows the bedding indicates that it was not a deep water rock, it was a shallow water rock. So we've crossed the major fault line, the Martic Fault, and we're now back in the shallow water North American rocks called the Laurentian terrain. And everything from here to Colorado is Laurentian terrain.
Oh, wow.
No fossils have been found in this rock either. There could be fossils in it. There is a possibility somebody may find some someday, but there are none yet. We think this rock is the bottom of the Paleozoic, lower Paleozoic, but that still is an educated guess, not a good determination. Now, the rocks here are on the edge of an anticline. Sugarloaf Mountain is a major fold, an upfold, and as we go in this direction, which is what we're going to do between now and the next stop, we are going into the interior of the folds. So that means the rocks are getting older and older. The interior of an anticline is the oldest rocks. The younger rocks are exposed on the outside edges, and that's where we are right now. We're on the outside edge. The fault itself, Martic Line Fault, is off in that direction. We crossed it a mile or two back, and it too is folded as well. So what appears to have happened is that the deep water rocks were pushed up and over the shallow water rocks, which we are in now. Then the whole stack, the lower shallow water rocks, the fault, the upper deep water rocks, that whole section was folded over. And it was folded over fairly early. The evidence that it was folded over fairly early is not shown in this area. That's extrapolating from outcrops that you can see in Pennsylvania. So again, it's an educated guess, not absolutely certain. Let's see. Actually, this is a good enough piece here. I did not explain, I asked the question, but I didn't give you an answer, why I knew that the layers in the inside of these deeper layers, there's a crevice in here. And the fizzing rock is exposed in the middle of the crevice. Let me put the acid on again. There we go. It's fizzing on the inside, but it doesn't fizz out here. There, I think that shows the fizzing.
Okay.
Good enough. The fact that it's a crevice was my clue, because calcite, limestone, is slightly soluble in acid water. And what has happened is this rock has been exposed to rain, and the rain has actually dissolved partly the calcite-rich layers, and left the calcite poor layers, or calcite free layers, standing up in relief. And so that's what made me expect that the deeper layers in the crack would fizz and the upper layers wouldn't. Okay, I'm going to take this rock. This will be a useful one to have in the lab because it shows the bedding very nicely, and it actually shows a trace of the cleavage as well. Okay, we'll go on to our next outcrop, which is at the top of the mountain. Now, you people have seen these rocks earlier, by the way, because some of the rocks we have in the lab came from this earlier.
Yes, I'll go back the other way.
Mud here. There we go.
Well, maybe I won't.
Now occasionally I rub some CBD oil every other day, so it